Ciphers, Ciphers, and More Ciphers. A look at cryptography with Mila Harris, Sammy Foster, Jasmine Gregg, and Kylie Dorsey. Cryptography is the study of methods to make and break secret codes. Encryption is the process of coding information to prevent unauthorized use. Cryptography is used when there is a desire for security against unauthorized interpretation of coded data. The process is to disguise this data is called encryption. Historically, encryption was used primarily for military and diplomatic transmissions. Today, it is used to secure electronic transactions of all kinds. The Caesar cipher, also known as the shift cipher, is one of the oldest and simplest forms of encrypting a message. Its purpose was for Julius Caesar to be able to send messages to his troops. It is a type of substitution cipher where each letter in the original message is replaced with a letter corresponding to a certain number of letters shifted up or down in the alphabet. For each letter of the alphabet, you would take its position in the alphabet, say 3 for the letter C, and shift it by the key number. If we had a key of 3 plus 3, that C would be shifted down to F, and that same process would be applied to every letter in the plain text. In this way, a message that initially was quite unreadable ends up in a form that cannot be understood at a simple glance. For example, math is super fun when encrypted ends up like this. The Caesar cipher can also be explained mathematically. In plain terms, this means that the encryption of the letter X is equal to the shift of X plus N, where N is the number of letters shifted. The result of this process is then taken under the modulo division, essentially meaning that if a letter is shifted past the end of the alphabet, it wraps around to the beginning. Decryption of an encrypted text, called the ciphertext, would be carried out by subtracting the shift amount.
So a decimation cipher is the method of encrypting a message by multiplying each position by a fixed number and using modular arithmetic. You start by assigning all 26 letters the numbers 0 through 25. So A equals 0, B is 1, C is 2, D is 3, so on and so forth. So the value of K is called the key. You choose any odd integer between 3 and 25, except for 13, to be your key, because for this to work, K and 26 must have no prime divisors in common. So for example, C's position is 2 and my key is 3. So I would then multiply the numerical value of my letter by my key to get my new letter. So 2 times 3 would equal 6. The letter attached to the numerical value, 6, is G, so the new encrypted letter would be G. If the numerical value exceeds 25, you use modulo 26, which means you subtract the value by 26 until you get a number under 25. So for example, the numerical value attached to K's position is 10, and my key is 3. When I multiply 10 times 3, that equals 30. 30 does not have a letter attached, so you do 30 mod 26, which equals 4. So the new encrypted letter is E. So you keep subtracting 26 until you get a numeral that is attached to a letter. So T's position is 19. The key is 3, so 19 times 3 equals 57. And 57 mod 26 would equal 31. 31 is still not under 25, so you would do 31 mod 26, which then equals 5. And that would give you your new encrypted letter as F. So an example of a full decimation cipher is here. So I used the message math is great, and I had the key of 2. So I find the position of each of my original letters, which is 12, 0, 19, 7, so on through the rest of them. And then I multiply all of these original positions by 2, which gives me 24, 0, 38, 14, 16, 36, 12, 34, 8, 0, and 38. So then I go through and I find all the numerals that are above 25, and I subtract those by 26 to get the new position. And then my encrypted message ends up being XAMOSKMIIAM.
All right, so next up we have the linear cipher. So this is basically building off of the decimation and both the Caesar cipher. So basically this is an extended version of the decimation. So our formula here is kx plus x times mod 26. So basically, as she talked about earlier, mod 26 is basically assigning a letter to each one, to each number. So it'd be 0 is A, B is 2, or B is 1, and so forth. So K is the key for the thing, and then S is the shift that we want to see. So this is usually just adding something to the decimation. So an example we have is K equals 11 and S equals 6 for the letter D, and then that so we put that into the equation, we get 39 mod 26, which ends up to be 13, and then 13 corresponds with letter M. And then we have a more in-depth example. So this is, we like ice cream, because who doesn't like ice cream? So basically, like I said, it's a lot like the decimation, except we're gonna have the +5 because our S equals 5. So we have our positions for each letter, and then our equation is right here, x3 plus 5. So this is the shift we see, and then this is the new encryption we have.
Okay, so today I'm going to be explaining the Visioneer cipher in Square. This is an example of the Square format, and then this is the example of a cipher. So this is a more sophisticated crypto system, and there's two different forms, which are the two that I mentioned here. The Visioneer cipher, what you'll do is you'll start with a keyword, and then you'll identify the numbers that the keyword's letters align with in the alphabet. And then from there, you'll assign each letter of the message that you're encrypting to a letter from the keyword. And then from there, you'll have the encryption. So for the Visioneer Square, the left column over here will be the letters of the keyword. And then the top row will be the letters for the message that you're encrypting. And instead of assigning numbers, you're going to just assign the letters to the keyword over and over again until you're finished. So an example of the cipher, my keyword is math, so M would be 12, A is 0, T is 19, and then H is 7, so that's 12, 0, 19, 7. And then my key message, or the message that I'm encrypting, is I like fries, so I'm going to go 12, 0, 19, 7 until the message is assigned to a number. So that number that's here is going to give me how many times I'm going to add from the position that the letter is in for the alphabet. So with I, it's position 8, and I'm going to add 12, so that gives me U at 20. And then the same thing moving on. And if your position is 0, then that means you don't have to add anything, and you just stay there. So after adding all of the numbers and going through, the key message, or the encrypted message, is ULBRQMDIXZ. And then we have the Visioneer Square, and this is kind of how you'll do it. So instead of assigning numbers, you're going to assign letters. So we'll keep the same keyword, which is math, and the same message that we're encrypting. So it'll just run MATH all the way through. So within the left column is where the math keyword is going to line up, and then where the top row is where each letter of the message that I'm trying to encrypt will go. So if I start with M and I start with I, and I kind of drag them, then I meet in the middle to U, and then that will give me the results of the ULBRQMDIXZ. So in conclusion, today we've looked at the Caesar cipher, the decimation cipher, the linear cipher, and the Visioneer cipher.